So in this lesson, we will focus our attention on improper integrals. Okay, improper, especially uh, when it has the upper limit or lower limit, or both limits are infinitive. Okay, so the goal of this lesson is, at the end of the lesson, you'll be able to determine whether an improper integral is convergent or divergent, and then solve problems related to improper integrals in business and economics. Okay, so these are the two goals. So the definition of definite integral a to b f of x dx, you know that it requires the interval ab to be finite. A is finite, b is finite. And also recall that the fundamental theorem of calculus requires that the function be continuous on AB. If the function is not continuous, then the integration or derivative doesn't exist. So, sometimes life is not that always easy. Instead of definite integral, instead of let's say 2 to let's say 100 f of x dx, sometimes we need to deal with like 2 to infinity f of x dx. So how do we evaluate this integral? As soon as there is infinite interval, then we cannot use the fundamental theorem of calculus. And if that is the case, then this problem cannot be solved. So what we're going to do here in this section is that we use a little trick and be able to evaluate this improper integral. So improper integral is something like this, when the interval is, when the limit involves infinity, then this is one type of improper integral. So we'll focus our attention on this type only. Okay, so let's look at example 1a. So let me just copy the question. 0 to infinity x squared plus 1 dx. So in order to make this, in order to convert or change this into definite integral and be able to use the fundamental theorem of calculus, we're going to use a little trick. The trick is, I'll write 0 to b, x squared plus 1 dx. Now we can evaluate this integral, right? This is now becomes a definite integral. Now b is a new variable that I introduce. It was not given there. So what I'm going to do is, what is b? I need to define that. So b is actually tends to infinity. Okay, you see, by doing this little trick, we are able to evaluate this definite integral. Now let us evaluate that. So limit b tends to infinity. You know how to evaluate that, which is x cubed divided by 3 plus x. The integration of x squared is x cubed over 3 plus 1. Integration of 1 is x, and 0 to b. Now integration is done. Now this problem is simply a limit problem. Okay, limit b tends to infinity, and you substitute that value, b cubed over 3 plus b minus 0 cubed over 3 plus 0. So we got limit b tends to infinity. It will be b cubed over 3 plus b. Now, if you evaluate this limit, so that's going to be infinity cubed divided by 3 plus b. So that means it is the whole, limit problem will be infinity, right? So that means when the value is infinity, we call it, the integral is divergent. When the answer, your final answer, is some definite number, meaningful number, we call it convergent. When you evaluate the limit, and if you get infinitive or negative infinitive or undefined value, then we call it divergent. So now let's look at part C, for example. In part C, negative infinity to 0 e to the 4x dx. So let's look at that, what happens. Again, in order to convert this into definite integral, I'm going to suppose that to be a, lower limit is a, upper limit is 0, because 0 is a finite value. So e to the 4x dx. Now I need to define what is this a. So that means a is limit a tends to negative infinity. All right. Now limit a tends to negative infinity, and you know how to find the, how to evaluate the integral of e to the 4x, which is e to the 4x over 4, and you're going to get a to 0. So integration part is done. All you need to do is evaluate the limit. So let us evaluate the limit. So limit a tends to negative infinity. And so I can write 1 over 4 outside. So that's going to give me e 4a minus e 0. Okay. You substitute the upper limit. Oh, I made a mistake here. Upper limit first. So you'll get e4 times 0 is e0 minus e raised to power 4a. That's what we got. Now, e raised to power 0 is 1. We know that. But what happens when limit a tends to infinity? So what happens as a tends to negative infinity? So your e4a tends to what? So remember this, e4a is negative infinity. So that means you can write that e negative infinity. So that's going to give me 1 over e infinity. So 1 over infinity is 1 over infinity. How much is that? I think we already discussed, which is 0. Okay, so this tends to 0. Make sense? Yeah. So then we can write this as 1 over 4. This is 1 minus 0. So that's going to give me 1 over 4. So now this 1 over 4 is definite value. So we call that the integral is convergent. So if you get a definite value, then it is convergent. If you get like infinitive or negative infinitive or some undefined value, we call it divergent. Any questions so far? Before we do any of the other problem, let us quickly review the integration by parts formula. Okay, integration by parts formula, whether you still remember that or not. Review integration by parts, IBP. Suppose you are given x ex dx, for example, then how do you evaluate the integral? I trust that everybody know how to evaluate this by using the integration by parts. And one of the idea to to evaluate this integral using IBP is a tabular method, in which you make a table there. This is your algebraic function and this is your exponential function, and we know the rule Liat, right? We know the rule Liat. So according to this rule, algebraic function comes first. So we do this, u means derivative, and we suppose that u to be x, and the remaining v is, we need to do the integration. So that is our e to the x. Okay, we know this, and here we'll have sine. So then what we're going to do here is we find the derivative of this x until we get 0. So derivative of x is 1, derivative of 1 is 0, and we are done. So now integration on this column, which is e to the x by itself and e to the x by itself. So the sign will be positive, negative, positive, right? So your integration is basically x e to the x dx is going to be this one, and this one. So basically we got positive 1x, positive 1 times x is x e to the x, and then -1 times 1 is -1 times e to the x is e to the x, plus 0 times anything is 0, so I don't have to write that. So plus c. We know this integration. Okay, any questions? It's just a quick review. Now let's look at this part. Which part is that? Part D. Let's look at part D. In part D, the question is 0 to infinity. Let me just copy. Oh, -infinity to 0. Sorry, guys. This one is -infinity to 0, x e to the x dx. Now, in this case, first you evaluate the integral, okay? First, evaluate x e to the x dx. So we already evaluated it here. Let me just copy and paste if I can do that. Okay, this guy will come there. Okay. All right. So we already evaluated this part. Now, one thing though, okay, one thing though here, first of all, I need to make this definite integral, which is a to 0 x e to the x dx, and I define that a to be a limit a tends to -infinity. Okay, now we consider that. First we find that we already got it, and therefore integration so we can write limit a tends to infinity, negative infinity, a tends to negative infinity, a to 0 x e to the x dx can be written as limit a tends to negative infinity, and this part, just copy that part. So we already did the integration, which means x e to the x minus e to the x, and because this is definite integral, we don't need c, right? So we don't need that c here. So a to 0. So we did the integration already. All you need to do is evaluate the limit. It's not a big deal. Let's see what happens if we evaluate the limit. So we got, first let us put the upper limit, which means 0 e to the 0 minus e to the 0 minus a e to the a minus e to the a. And what is a is limit a tends to negative infinity. Okay, so this one is no more integration. It's simply a pre-calculus, evaluating the limit. Well, calculus 1, I would say, just the limit problem. Now this part will be 0, of course, minus this part is 1, e raised to power 0 is 1, minus here. Now tell me, a limit a tends to negative equals what? Try to figure that out. Also try to figure out limit a tends to, not infinity, sorry, negative infinity, and a tends to negative infinity, e raised to power a equals what? I want you to figure that out. This will be 0 and this will be 0. Okay? Okay, thank you. So that's going to give me 0 minus 0, which is, the answer is -1. So that means what? It is convergent or divergent? Convergent. Done. Any question? Okay, so if you don't have any question, now let's try one more example, very quick. This part E. So part E, before we do part E, well, let's begin part E. Negative infinity to infinity, e raised to power negative x over e to the negative x plus 2 square dx. So this integral looks little ugly, right? Little complicated, but it's not actually. So first of all, when you are given both lower limit and upper limit as infinitive or negative infinitive to positive infinitive, what you can do is you can separate them by using any number here. So it all means, for example, when you are given something negative infinity to infinity f of x dx, what it means is it represents the area from negative infinity to infinity, all this area. So what we can do is we can split that into negative infinity to 0 or any number, 0 or 10 or whatever, f of x dx plus 0 to infinity f of x dx. Okay, so that means this area and this means this area. So this area plus this area should be the whole area. So we can split that way. You don't have to split it exactly at 0. You can split anywhere, but to make life easy, I'm supposing 0 there, okay? The splitting, the dividing point to be 0, just to make life easy. But you can choose any value, any number there. So I'm going to do negative infinity to 0. So I'm going to split that into negative infinity to 0 e to the negative x over e to the negative x plus 2 square plus 0 to infinity e negative x over e negative x plus 2 square dx. Okay. Now, in order to make this definite integral, what you may want to do is limit x tends to a to, not x tends to a tends to negative infinity. So a tends to negative infinity, a to 0, e to the negative x over e to the negative x plus 2 square dx. Oh, I forgot to write dx there. Plus limit b tends to infinity, 0 to b, e raised to power negative x, e to the negative x plus 2 square dx. Now consider just the indefinite integral. Let us first evaluate the indefinite integral and then we substitute the value. Okay, let us evaluate this first. Guys, what do you think? Which method would be the best one to evaluate the integral for this kind of integral? Any idea? Simple antiderivative rule is not going to work. So if that doesn't work, then the next line of thought would be, can we use substitution rule? If we can, then we go for that. If not, then we think about integration by parts. Okay, but here it looks like u substitution would work. So let us suppose that u equals e to the negative x plus 2. Then your du over dx is going to be e to the negative x and negative x there, which gives me du equals negative e to the negative x dx. So I can write negative du equals e to the x dx. So now substituting the value here, what do I get is e to the negative x dx is simply negative du over, this is u square. So which gives me negative u negative 2 du. And you know how to evaluate that. So that's going to give me negative u negative 2 plus 1 over negative 2 plus 1 plus c, which means okay, which means 1 over u basically, right? Because this negative and negative will be positive, and u power negative 1 is 1 over u plus c. So substituting the value back, substituting the value of u back, so you're gonna get the integration is going to be 1 over u is e to the negative x plus 2 plus c. That's what we got. Now we can, you see, we already know the integration of this part and this part, antiderivative of that. So let us substitute that. So this guy will be, so the integral is let me just copy that, limit a tends to negative infinity, a to 0. Oh, I can just put that as 1 over e to the negative x plus 2 a to 0, right? Because we already did the integration. All you need to do is just put the limit, which is a to infinity, I mean a to 0, plus in the second part, limit b tends to infinity, and 1 over e to the negative x plus 2, and just all you need to do is 0 to b. Integration is done. All you need to do is evaluate the integral. Can you guys evaluate the integral and let me know what do you get? So this one, if I put the 0 there, limit a tends to negative infinity, it will be 1 over e to the 0 plus 2 minus 1 over e to the negative a plus 2 plus this guy will be 1 over e to the negative b plus 2 oh, I forgot to write the limit. Just let me copy the limit here. Limit b tends to infinity. This is 1 over e raised to power negative b plus 2. Just substitute the upper limit minus substitute the lower limit, e raised to power 0 plus 2. Okay, so here you'll get 1 over 3 because e power 0 is 1. So 1 over 3 minus this part is 0 plus this guy will be 1 over, this is 1 over 2 minus this guy will be 1 over 3. Okay, that's what we got. Now if you simplify, it will be 1 over 3 plus this is how much? 1 over 6, which gives me 1 over 2. So that is your answer. That means the integral convergent or divergent. Of course, the integral is convergent, right? Okay, so integration is not that bad, but it requires a lot of limit evaluation of a limit, okay? Just the algebra, lots of algebra here. Be careful on that. Okay, if you have any question, let me know. Otherwise, we move into the application part. Okay, let's move forward to the application. So application of improper integral. Definite, you know, the capital value, have you heard capital value before in your economics or commerce course? So what is capital value? Capital value of an asset is also defined as the present value of all future net earnings of the assets. In other words, it is accumulated present value of a continuous money flow into an investment at the rate of R of T dollars per year, perpetually means for infinitely many years, which is given by, this is the formula for capital value. just by reading the definition. If you understand, great. If not, then don't worry. So let us work with example 3. And with the help of example, it's easy for me to explain what is the meaning of capital value. Okay, so let us work this example 3 and we'll understand the meaning of capital value in the context of this example. So remember this formula. The formula will be given to you in the exam, but I suggest try to memorize if possible. Now in this example, what is given? Find the capital value of an asset that generates $5,000 yearly income here forever. Okay, maybe I should have added that word, forever, if the interest rate is 10%. So what is given here is your K of t, which is the K of t represent the income. Okay, K of t represent the revenue or income, is given by, which is 5,000 per year, and rate R is given 10%, and you can change that into 0.1 if you change it into decimal. These are the two things given, right? And we know the formula. So we know capital value equals 0 to infinity K of t e minus RT dt. So that's the formula for capital value. So which gives me, this is 0 to infinity. K of t is given 5,000. Let me just copy that. E minus R, R is 0.1 t dt. That's it. And we already know how to evaluate this integral, okay? So this integral becomes, let me go from here all the way there. So this integral becomes 0 to b. Let me write 5,000 outside to make life easy. And so limit b tends to infinity. And what I'm left with is e raised to power negative 0.1 t dt. And you already know how to evaluate this integral. So limit b tends to infinity, 5,000, and this guy will be e raised to power negative 0.1 t divided by negative 0.1, and limit is 0 to b. Okay, so which gives me limit b tends to infinity, and 5,000 divided by 0.1. What is that? 5,000 divided by 0.1. I believe this one is 50,000. And since there is a negative sign, I'll write negative 50 there. So remember, 5,000 divided by 0.1 is 50,000. Okay. So, and then there is negative sign. So now all I need to do is e raised to power negative 0.1. I put the upper limit, which is b, minus e0. That's it. Now let us evaluate this. Notice that as b tends to infinity, your e raised to power negative 0.1 b tends to 0. Okay, this will be 0. So that's going to give me negative 50,000. And this part is 0 minus 1, which will be negative times negative will be positive $50,000. This is your capital value. So therefore, your capital value is $50,000. Now, what it means is, let us go back to the questions and try to understand the meaning of capital value in the context, okay? It says that what is the value, present value, and if you keep that amount, what is the present amount that you keep in the bank, and the bank will pay $5,000 for infinitely many years if the interest rate is 10%. So that means $50,000. So if you put $50,000 in your bank account, and if the bank pays you 10%, generally they don't pay 10%, I know that, but let us assume, so in math we can actually live in the world of imagination. So let us suppose that the bank pays you 10% interest, and if you put the $50,000 in that account, you can draw $5,000 every year for infinitely many years. That's what the meaning of this. Okay, any question, guys? All right, so let's look at this example for quickly. Suppose that a large farm with a known reservoir of gas beneath the ground sells the gas rights to a company for a guaranteed payment at the rate of 10,000. Oh, 10, this is a typo. This is 10,000, guys. Okay, 10,000 e raised to power. All right, this is 10,000 e raised to power 0.04 $t per year. Find the present value of the perpetual stream of income, assuming an interest rate of 12% compounded continuously. So you need to find, you see here, the 50,000 is the present value that will pay $5,000 for infinitely many years. So in the same way, if your revenue is this, well, this is the revenue, and you need to find how much money should be there, what amount should be put so that you can draw this much amount, 10,000 e raised to power 0.04 t for infinitely many years at the rate of 12. So let us list what is given. Here what is given is k of t is given. K of t represent the income stream, which is 10,000 e raised to power 0.04 t. And what is r given? R is given 12%. You can change it into 0.12, and all you need to do is capital value is integration 0 to infinity k of t e minus rt dt. This is the formula, and the proof of the formula is not required for this course. So you will get 0 to b, you can write, and you can take the limit. B tends to infinity. So k of t is 10,000 e raised to power 0.04 t, and then in the formula there is e minus r. Minus r is 0.12 t dt. Now in this case you can combine this e and this e. When you combine that, because they have the same base, how do we combine it? Recall from your middle school. Okay, we can write, let me write that 10,000 outside to make life easy. And so here you have left with e raised to power 0.04 t minus 0.12 t dt, right? When we have the same base, we just add the power. So we're going to get 10,000 limit b tends to infinity, and so you'll get 0 to b. So how much is that? It will be negative 0.08 t dt. And I trust that you can complete this by yourself. Okay, try to complete it quickly now. And this much for this lesson. So we have done lots of things. Okay, we started with the improper integral, and we learned when the integral convergent, when the integral divergent, and then we also apply the improper integral to solve real world problems, especially from business and economics.